Hey guys, welcome back to another A-level maths revision video. In this video today, we're going to take a look at iteration. Again, pretty brief topic, should hopefully be quite straightforward. So the good thing about this topic is you can use your calculator for a good chunk of it. So you can see that for question 1 here. You can use your calculator to find the next few values of this iterative formula. But what we'll do is we'll do it by hand for the first one, and then the rest we'll just assume we're doing it with the calculator. So let's take a look at this question here. So what we've got is we've got this equation, y is equal to minus x cubed plus 2x squared plus 2. And we know it intersects the x-axis at the point A, where x is equal to alpha. So essentially, we have this root here, okay, at A. Now, we want to find an approximation for alpha, the root, using this iterative formula. And what we're going to do is we're going to start with the first value being 2.5. So what's happening here, essentially, if this is something that you've not done much of, what we're doing here is we're going to take this first value, x0, which is 2.5, and we're going to use this xn plus 1 formula. And what this does is this keeps giving us a new value. So this is 2 divided by the previous one, so this is xn, and we square this, and then we add 2. Okay. So, for example, if I want x1 now, that means n must be 0. If we just want x1, so x1, so that's going to be 2 divided by x0, because this is xn, where n is 0 for this one. So for x1, n is 0. This would be x0, which is 2.5. We're going to square that, and then we add 2. Okay, plug this into your calculator, and what you should get for the first one is 2.32. Okay, now that's just literally what we get on the calculator, so we can't give it to 3 decimal places, so we're going to need to do that for the next couple. X2, again, same process. We want the next term now, so we use the previous term in our iterative formula. So we do 2 again, we divide it by the previous term, so the previous one is 2.32. Then we square that, and then we add the 2 on. So, plug that into your calculator, and to 3 decimal places, what we should get is 2.372. Okay. Again, let's keep going. x3. We do 2 divided by the previous term, 2.372. We square this, and then we add 2 again. And what will this give us to 3 decimal places? This gives us 2.356. And then finally, x4. We do 2. Again, this is getting a little tedious, but we divide it by the previous term, and then we square it. And not forgetting to add the 2 on. And if we work that out, that gives us 2.360. Okay, so then our first 4 values there, x1, x2, x3, and x4. Part B, we want to show that alpha is equal to 2.359 to 3 decimal places. So the easiest way to do this is considering an interval. So if we just cut this off here, so part B, what I'm going to do is I'm going to consider an interval for this. So, for example, if we want this to 3 decimal places, so if alpha is 2.359 to 3 decimal places, what I need to do here is consider an appropriate interval. So the easiest one to consider here for 3 decimal places would be 2.3585, and then similarly 2.3595. Okay, we consider this interval. So what do we do with this interval? Well, we consider it with f. So that's our original y here, that's our function. So if I plug f of 2.3585 in here, what we'd hope to find is that one of them is negative, and if we plug the other one in, hopefully the other one will be positive. So basically we need one negative, one positive, because in that case what we find then is that the root must clearly lie within that interval. So if we do the smaller of the 2 values first, 3585, So this now, we're just going to plug it into our y equals, where x is this value here. So for example, we'd do minus 2.3585 cubed plus 2 lots of this squared, and then we add 2. Okay, so I've already calculated this on my calculator, but have a go, make sure you get the exact same, and you should get minus 0.00142, or something very, very close to that, depending on how you round him. Essentially, you should find that it's negative. Okay, so that's less than 0. And let's do the same now. F of 2.3595. And hopefully, if we haven't made a mistake, this one should come out positive. And on my calculator, I've worked this out to be 0.00584. Okay, so one positive, one negative. So what we say here is by the change of sign, between 2.3585 and 2.3595, in that case, alpha must be 2.359 to 3 decimal places. Okay, so there we go. So that's question 1 there. Like we see, 6 marks for that. Pretty standard. These questions don't change too much, but I think using the calculator is easier for what we've done here in part A. You'll save yourself a lot of time. Okay, so let's have a look at this next question then. This one's a little bit trickier, seeing as we're involving a bit of trigonometry, but it doesn't change anything too much. Again, it's just an iterative formula, so the method and the working is pretty much the exact same. Part A is something that we haven't done just yet, showing that the root is in the interval, although it's similar to what we just did with part B there. So we've got this interval 1.2 to 1.3. So if the root alpha of f of x is in that interval, what we'd hope to find basically, again, is that one of these is positive, one of them is negative. So all I'm going to do then is substitute 1.2 into my f of x, so f of 1.2. So f of 1.2, what would that give us? So that would be 4 cosec 1.2 minus 4 times 1.2 plus the 1. And if you work all of that out, what you should get is 0.4916, so on and so on. So that one's positive. So hopefully, when we put f of 1.3 in here, we should get negative. And again, similarly, that will be 4 cosec 1.3 minus 4 times 1.3 plus the 1. Work all of that out, and what you should get here is minus 0.0487. Okay, so again, we have a change in sign. So we have a change in the sign, and what we can also say here is that f of x is continuous. That is actually quite important. So, and f of x is continuous. So f of x is continuous. So therefore, alpha is a root. So we have the root alpha. Of f of x, where alpha is in this interval here, 1.2 to 1.3. Okay, so that's part A. Hopefully no issues there. Part B, this again is quite a standard one. Basically, we've got this original f of x, and we want to show that we can actually rearrange it to be the given f of x, the given equation here. So this just comes with practice. Once you've done a few of these, you should find these pretty straightforward. But take a little bit of a look at what we've got again, and then take a look at our original expression. Now, 4 cosec x. So 4 cosec x, that's the same as 4 over 2 cosec x. So 4 cosec x, what would that give us? So that would be 4 cosec 1.3 in here, 1.2 to 1.3 plus the 1. So if we work all of that out, what you should get is sine x. And we've got this plus 1. Now, our final expression is 1 over 4. And our final expression is just 1 over sine x rather than 4 over sine x. So what's immediately jumping out to me here is that I'm probably just going to be dividing by 4. 1 over sine x, that's just 4 over sine x divided by 4. And then 1 divided by 4, you get your quarter. So if I rearrange this now, so 4 cosec x minus 4x plus 1 is equal to 0, so that's what they're saying, f of x equal to 0. I'm going to take 4x over onto the other hand, onto the other side. So I get 4x is equal to 4 cosec x plus 1. And if I divide through by the 4 here then, I should get exactly what we need. So x is equal, so 4 cosec x, that's what we've got here. That would be 1 over sine x. And finally, 1 divided by 4. We get our quarter there as well. Okay, so part B, nice and easy. Part C then, so we need x1, x2 and x3. This is using iteration now. And like we just previously mentioned, it's a lot easier if you use your calculator. In this case, what you're going to do is you're going to put 1.25 into the calculator first and then enter that. So what you're doing is you're storing that into the memory of the calculator. And what you're essentially going to do then is 1 over sine of the answer, which it stores has the 1.25, and then you need to add a quarter. Now if you press enter here, that gives you x1. So what you should get here for x1 is, I've lost my working, what did I get? For for x1 even, I got 1.303. The answer is to 4 decimal places, so to 4 decimal places that will be 1.3038. Okay, so that's x1. And then x2, it repeats this process, this time storing this as the answer. So if you press enter again, x2 gives you the new value. In this case, it'd be 1.2867, so 4 decimal places. And then finally, doing this one more time for x3, what you should get to 4 decimal places, I'm having a nightmare here today, is 2917. Okay, so that's x3 there. And then finally for part D, very similar to what we've just done, the end of the last question, we want to show, using the change of sign of f of x in a suitable interval, that alpha is equal to 1.291. So basically, the root is 1.291 to 3 decimal places. So again, consider your interval, with it being 3 decimal places. I'm going to consider f of 1.2905 and then f of 1.2915. Okay, if we work each one of these out individually, one should be positive, one should be negative, and if we get that, then using change of sign, alpha must be 1.291 to 3 decimal places. So 1.2905. So be careful here, we're plugging that into our f of x. So this would be f 1.2905. So for example, that would be 4 cosec 1.2905 minus 4 times this plus your 1. Okay, you need to plug all of that into your calculator. If you do that correctly, what you should get here for f of 1.2905 is 0.00446, pretty small. And then for f of 1.2915, hopefully we're going to get a negative. And if you do it correctly, you should get a negative as well. We get minus 0.00475. Okay, so that's good. We wanted one positive, one negative. So, as we have a change in sign, and again, let's just iterate that f of x is continuous. In that case, alpha is 1.291 to 3 decimal places. Okay, and there we go. So that's part D done there. for the last 2 marks. Moving on to this final question here then. We've got f of x equals 3x cubed minus 2x minus 6. We want to show that f of x equals 0 has this root alpha, which is between 1.4 and 1.45 to start with. So let's have a look at that first. So to start with here, again, just like we've been doing with the previous questions, we need to consider the change in sign. So question 7, part A. So if it's between 1.4 and 1.45, we're going to consider f 1.4 and then f of 1.45. So if we do this, we should expect 1 positive, 1 negative, and we're on to a winner. So if you do f of 1.4, that's going to be 3 lots of 1.4 cubed minus 2 times 1.4 minus 6. So if you do that correctly, what you should get is minus 0.568. Okay, so minus 0.568 for 1.4, and then substitute 1.45 into f of x again. And what you should get here is 0.245875. Okay, so therefore we have change in sign. We have the change in sign, and f of x is continuous. So therefore alpha must lie in this interval 1.4 to 1.45. Okay, so that's part A done. Nice and straightforward. Let's take a look at part B then. So again, another standard show that question. This one a little bit trickier than the previous, but not too bad. So we want to show that the equation f of x equals 0 can be written as the given equation. So all I'm going to do first is write out my f of x is equal to 0. So 3x cubed minus 2x minus 6 is equal to 0. First, I'm going to get this in terms of x cubed. So notice my final line of working is the square root. It's just a square root, right? Rather than a cube root, for example. So what I know is then is that my penultimate line of working must be an x squared. So if I just write this out first, what I'm going to do. Okay, so that's my next line of working. Just taking this across, remember we want this in terms of x cubed for now. Next, we can divide through by that 3. Notice we've got 2 over x and 2 over 3. So if I divide through by the 3, I'm going to get something pretty close. So do that first. That'll be 2x over 3. And this will be 6 over 3, which is just 2. And this is looking pretty good so far. We've got 2x over 3. They've got 2 over x. So, and they've got 2 over 3. So 2x over 3, that matches to their 2 over 3 pretty close. And 2 over x, we've got a 2. So what's jumping out to me here is to divide through by the x. So we've got an x cubed, divide through by an x, so that'll give us x squared is equal, so 2x over 3 divided by x, that'll just be 2 over 3. And then finally, if you take 2 and divide it by x, that is just literally that, 2 over x. So therefore, to get x, we just take the square root here of both sides. So that's the square root of 2 over 3 plus 2 over x as required. And clearly we can't have x being equal to 0 because we'd end up with a denominator of 0. So that's part B, 3 marks there. And then finally, for part C, just using iteration. So if we have a quick look at this, again, we're going to use calculator this time rather than actually trying to work it out by hand. It's a good habit to get into. It will save you a lot of time, so I would definitely recommend learning to do this by calculator rather than sticking with this by hand. So what we've got here is our x naught is 1.43. 1.43. So what I want to do here is work out x1, x2 and x3. So again, store the 1.43 into the calculator's memory. And then you're going to do the square root bracket 2 divided by the answer plus 2 over 3. Okay, if you do this correctly, and you can do this by hand if you do prefer, it makes a bit more sense. X1 will simply be, so if I write the first one out by hand, this is what you should get. So it'll be 2 divided by 1.43 plus 2 over 3. Do that correctly, and what you should get is 1.4371. That's x1. Do the same now for x2, but I'm doing this on my calculator now. So my next one to 4 decimal places is 1.4347, and then finally x3 is 1.4355. Okay, so that's x1, x2, and x3 to 4 decimal places. So that brings us to the end of this video. Like always, I hope this has helped. And again, any issues, any errors that you spot, please let me know down below. Cheers.